So Victor and I have pretty similar backgrounds. We both grew up in Russia. Actually, only Victor grew up in Russia, and I grew up in America. Uh, but our common history begins on the Angular team. So we both worked at Google together on the Angular team. So I joined when AngularJS was somewhat young, but starting to get noticed, and worked on that for several years. Then Victor joined, I think, probably a year after I did, and worked on Angular Dart. And then the whole team then started working on Angular 2, which is now just Angular. Yep. So we both built, when I say we both built a good part of Angular, I mean, Victor did most of it, and I built a few little things here and there. Victor let me collaborate with him and be his rubber duck on a few of the designs. So I take credit for like the dependency injection and change detection and stuff like that, just because I was there. I focus a lot on performance on the team, so some of the performance tooling and mobile support. So things to like we worked with the Chrome team on things like App Shell and pre-rendering. So Angular was one of the earlier frameworks to support pre-rendering first class, and also we worked a lot with tooling teams on bundling and things like that. But Victor and I, after we released Angular 2, Victor and I left the company and started Narwhal, with the original intent of being an Angular consulting company. So we would basically say, okay, all these companies are wanting to move to Angular 2. Let's help them do it and, cash in on all the work we've done. Actually, we had other reasons. We weren't just looking for cash, but we knew there was a nice market opportunity. And so I wanted to get back to my entrepreneurial roots. Victor wanted to move back to Canada. And so so we decided to leave, and that was most of our business for the first. It is still like part of our business. We have a lot of Angular folks, and we're still leaders in that market. So we do help with a lot of like AngularJS to Angular migrations, things like that. But NX became the focus within the first year of the business, because as we got out there and saw how companies were actually building with Angular, building JavaScript. Like people were using Lerna in interesting ways, but it still left a lot that you had to do yourself on top of it. And it only solved one slice of the Monorepo puzzle. And we came from Google, which has one massive Monorepo for all projects, with a couple of exceptions, but it's like tens of thousands of projects in the same repository, with no branches or anything. So it's like, every change list like it increments. And I don't remember how many change lists there have been inside Google, but they had crazy tooling to support it. And there's nothing like it outside. And so we built NX as an answer to teams that we saw who wanted to have hundreds of developers working in the same repository across many lines of business, where there's a lot of sharing and a lot of composition and things like that happening. But build times were crazy. Managing those projects, managing dependencies and versions and branching, all this stuff there was really difficult. And so NX has evolved over the past 4 years to solve more and more of the challenges that come with developing at scale.
Mm-hmm. Yeah. Do you have a? Oh, sorry, Victor.
No, it's good. No, it's good. I think it's perfect. Like said much better than I could have said. Go ahead. Sorry.
I was thinking this would be very helpful if is there a list of the jobs that in part of your assertion of the comparison between Turborepo and NX, Turborepo basically is a task runner right now, whereas you do a lot more. What is that list of a lot more? I think you had the list partially on the Turborepo versus NX page, but is there a comprehensive jobs to be done analysis?
I think that page is good, but that page we sort of intentionally, because that page is meant for people who perhaps know or read about Turbo, so they can see, that's what I think Turbo is doing. So let's see the side by side. So it emphasizes the part that Turbo can do. So most of the things you see in features is what Turbo can do, right? Such that we can, at least to some degree. Turbo is a newer project. It's a much smaller project.
So for yeah.
Yeah. So, but there are sort of different layers in here, and I can. So in terms of what Turbo can do, if you look at the sort of side by side thing, right? There are certain things that you have to do to do a monorepo, right? There are two main aspects of the monorepo in general. One is you want to scale performance-wise and say, well, if my repo grows, the number of projects grow. For things to remain fast, certain things have to be true, right? And here we have things like figuring out what is affected, for example, right? Or doing task coordination. So you can say local task coordination, run 20 things in the right order in parallel on one machine, right? Doing computation caching, which is the idea where before you run a task, you figure out the value for the computation. You're saying, oh, I have this value. Have anyone else, or like, have I computed this thing, or anyone else on my team or CI computed this thing? Or yes, okay, I can use their result, right? Those things you have to do. Not all of them necessarily, but many of them you have to do if you really want to remain fast as your repo grows, right? The most interesting things in that sort of bucket of things are distributed caching, and that you basically want to say that if you want to be fast, just local caching is not enough. You need to share the cache with your peers, because obviously if you have 200 developers working and stuff, the vast majority of things can be computed in advance. Not exactly true for all projects, but many of them can be, right? Especially when it comes to CI, because CI you run things all the time. There's a lot of cache hits in CI. Figuring out what is affected and say, no, I have a change set. I have, let's say, 10 projects consisting of 100 libs in my repo. I make a change. So what part of the repo can be affected? Not necessarily is affected, but can be affected by my change. So I can try to figure out that in terms of rerunning, retesting stuff, right? And the affected part is put not just for performance reasons. Performance is one part. Of course, if you are you're running a tenth of the thing, it's good. But also for ergonomics. If you imagine a repo with 10 or like let's say 10 large apps consisting of many libs, right? You don't want to see a giant output of everything every time you run anything, like any CI, right? Any CI run, any PR, right? Because then it's not ergonomic, right? That's an important part of Monorepo. That Monorepo is not just fast. The ergonomics, dev ergonomics is also important. If you have many things in the same place, well, you better be good at presenting relevant information as a user, because otherwise they just be overwhelmed and say, okay, that's garbage, right? When it comes to perfect distributed task execution, affected and distributed cache, right? DTE, distributed task execution, is sort of the most, by far, the hardest one to implement, right? Because we're not talking about DTE as in, there are basically two main ways to do DTE, right? Both people do it. One is sort of what open source world does, which is like, you're saying, oh, I have 1,000 tests, or I have 10 machines. Well, I'm going to split the test into 10 buckets. Let's say weight them based on how long the tests take. So they are roughly the same time, right? And run them on 10 machines. It's a sort of sharding binning kind of situation, right? And that works to some degree. It doesn't work perfectly. At some point, if you scale, you have 20 machines running. For some of our clients, they have like 70 agents running tests on Jenkins. So you cannot have 70 bubbles on Jenkins that you need to click through to find what failed. Okay, that's just ergonomically just not working, right? The second problem with that, of course, is that it doesn't respect dependencies. So you cannot do builds this way. You can only do tests this way, right? If you're doing builds and you're saying, I need to build things in the order, well, then you cannot just split things into 10 buckets, right? Because you need to actually execute the graph in the right order, right? So that is by far the hardest one in terms of implementation, performance, and also dev ergonomics. Because again, if you have 70 agents running, you cannot just show 70 things in there and expect the developer to be, figuring shit out. Now you have to kind of present, like at Google, right? The way you present it is there's a single run, right? Whether it run on one machine or 1,000 machines, it doesn't matter. It looks the same. Right? And because it looks the same way, you can run a thing very fast on many machines, but you don't lose anything dev ergonomics wise. It's exactly the same, right? So that's sort of the tricky part in DT that I think took us a lot longer than, like with caching, it took us really like 2 days to build caching, right? Distributed caching. With DT, it took us a year. Okay, so the difference in effort is very big, right? DT is very hard to do it ergonomically. So that's sort of the performance part, where Turbo does some of it, not everything, right? It doesn't do, for example, DT right now, but it does some of it, so it can sort of attack the same problem, right? The second part of
I was just going to say, like DTE is distributed task execution is it's so important because it's when you have a worst case scenario, like when everything needs to be rebuilt in the Monorepo, which and at Google that's never the case, but it
happens sometimes. You sometimes jump on a train or whatever. Yeah. But yeah.
A lot of it needs to be rerun.
Yeah.
But that's when it doesn't, like there's the affected computation isn't going to give you anything. The distributed cache isn't going to give you everything. Like everything is new and fresh, and the cache isn't valid for the build. Then DTE is your only hope.
That's actually a very good point. But that's point that there are basically two main times you care about, right? One is you care for the average time, and you're saying, well, on average, I'm rebuilding about 10% of things, and I have 70% of cache hits, or 30%, some number of cache hits, right? And the average time is one thing, and then sort of the worst case scenario time, right? The average time you care about deeply the most, because most of the time you're roughly like, it's basically like a bipolar distribution, right? You're usually somewhere in here. Let's say your average time on CI is 15 minutes. For a large enterprise project, that's good. Most large enterprise projects suck at CI, so it's much worse than this. But 15 minutes is pretty good. You're like, okay, that's pretty bad. It's not bad, right? But if your worst case scenario time is 5 hours, it's still unworkable. It doesn't matter to your average time 15 minutes. If once every couple of days you hit a 5-hour run, That's it. Right? That cannot be allowed, right? So you have to say, okay, the average time is important, but the worst case scenario cannot be that much worse. It can be half an hour, 40 minutes. You can make it, but it has to be somewhere in the same ballpark, right? And distribution is the only way. There is no other way to make the worst case scenario, because when you have to redo everything, you cannot be basically smart about redoing a part of it. That's the average case time. Right? If you're smart about figuring stuff out of using cache, you can be smart in that area, right? But sometimes being smart doesn't help you. If you change every single line in your repo, or like every single file, you go and just massively do a massive refactoring, right? Well, then being smart is not good to use, right? You have to redo everything, so you have to distribute, and distributing ergonomically, where it presents you with a view as if you didn't distribute, right? Like Google, Facebook, or most large tech companies do internally, right? It's tricky because it's not just that you need to distribute, you need to build tooling to present the information correctly, right? So you need to have UI built for it. You need to integrate with source code management. Like it has to be a full stack integration where you run it, you see a card on GitHub, you click on GitHub, there is special UI. Because again, if you run everything and you run 3,000 projects, well, there is no use of showing the terminal output for 3,000 projects. It's too many. Like you have to be able to filter this stuff out, see what failed, what happened where, etc. So there is extra things that come with distribution that you have to tackle, right? And it doesn't matter for smaller projects, but the moment you go sort of small scale enterprise, not even large enterprise, but sort of like you have to figure stuff out really well, either a bespoke solution, and a lot of our clients do bespoke kind of solutions, right? Or you have something that is built for you. And so that's sort of this, but it's one part of the whole Monorepo thing, which is fast, right? Fast is important, right? If you're not fast, it's a no starter, right? The other part, which is equally or more so important, is not because you can be fast in a bespoke way. It's much harder to do the second part in a bespoke way, which is scale with the team size, with org-wise, basically org scale, right? Because a lot of folks who talk about Monorepos Savkin, right? Like, oh, Monorepos don't scale, and end up being big ball of mud. I cannot manage anything. Goodbye, like this, I'm not happy with it. They actually have a legit experience. That's how they experienced it, truly. And they're smart people. They're not stupid people. They just didn't have the right tools. So as a result, they have a giant bucket of code where everything can import, like there's basically no structure imposed to it, right? Well, yeah, that's going to suck, right? The analogy I use is like if you have 100,000 line of JavaScript, that's very hard to maintain. 500,000 line in TypeScript is easy to maintain, even though it's much bigger, right? Like good tooling actually makes a big difference. You can actually like do 10, 20 times bigger projects, much simpler if you have a tooling that supports you, right? So that's sort of the second part of the Monorepo thing, that you have to have a tooling that makes sure your repo doesn't end up being like this, right? One simple example is visibility rules, right? Like if you use TypeScript, you have private and public, but private thing, it matters, right? Whether, there are different ways to ensure privacy, closure, blah, blah, but, some form of information hiding is key. In the Monorepo, the same, right? If you look at tools internally, like Bazel or Baku or whatever, every other tool that large companies use, there is notion of privacy. You can say this package or this, this unit is private to my team. No one else can depend on it. It's private, right? And that matters. Like that's just one example. There are obviously, dozens of examples that help you with org scaling in terms of consistency and other things. But also there are two main areas. One is fast, right? And the other one is org scaling. And if you have an open source project with 3 packages in it, okay, org scaling is irrelevant to you. Okay, you can figure it out just by drawing a piece of paper, right? But if you look at the larger one, the org scaling actually matters more because you can try to work around fast. But if your stuff ends up being a big ball of mud, it's hard, right? So it's like you can try to make JavaScript. Back in the day, JavaScript was slower. You can try to make a system super fast, with or like do some manual bundling or tree shaking back in the day, right? To deliver a fast web app. But it's very hard to avoid a mess if you have 500,000 lines of JavaScript in the same repo. Right?
Which is one of the reasons why enterprises just rewrite things every few years and stuff.
Yeah.
Or have legacy code bases that they don't maintain, and nobody wants to touch.
Yeah, because you cannot maintain it, right? So the second part is where, like, I think it's more interesting, right? In terms of there are many different ways to approach it, because fast is actually, DT is the only really hard part of fast, I think. The rest you can there are so many tools with a history that you can just borrow ideas from, right? Or be inspired by. Let's just be, and make something similar, which is totally fine, right? That's what you should do.
Which all of our ideas are,
exactly.
We're derived from Bazel.
We look at Bazel, internal Google tool, like what Bazel does, and the tooling around it, with like test visualizations, test outputs, and everything around it, and say like, what does Bazel do? Bazel does really good, a lot of fantastic things. Unfortunately, it's super hard to use outside of Google, and it's not very ergonomic. okay, how can we borrow those ideas, make it simpler so it's more ergonomic, right? Like ideally very ergonomic, right? And gives you most of the same benefits, right? So a lot of it is borrowed from Bazel, which I'm not ashamed to admit, right? Very, very, very smart engineers build Bazel, so it's no shame in borrowing some of the ideas that they, came up with, because they clearly, they clearly work, right, for companies like Google and Facebook, etc.
One thing I wanted to establish is some idea of order of magnitude. I worked at Netlify when it was like 50 people, we grew to 200. At some point in there, we started to need to do the migration, but I don't know, like it was a very messy thing because it could never really be justified apart from like we think we have these benefits. Do you find like people have trouble justifying it, or do they just throw everything out the window and rewrite everything like you said?
I think that the migration part, actually, that's a very good. It's an interesting plug into our migration thing. But you can, Jeff, answer first, and then I will talk about our migration thing.
So I missed the first part, like migrating from what to what.
So like a lot of companies, they start out, they think they're small and like we'll keep it simple. Like let's not do monorepos. It's just gonna keep things independent. And then as they grow, they're like, okay, I need to a lot of these things have cross dependencies and so on and so forth. You know the benefits, but they already have all this structure set up. And it's a whole thing to like move over.
That's how we make all our money, is the teams who are like who feel the pain of multi repos and understand the trade-offs of monorepos and have decided that the trade-offs err in the favor of monorepos. And so most of our business is helping teams do that. We've got 30 some engineers or something that most of
so like a consultancy type thing on that side. Okay.
Yeah, they can. Okay, go ahead.
Yeah. No, I'll say also like the other thing for monorepos, like the reason I personally stayed away from it is because I only heard about Facebook and Google all the time. And I'm like, okay, I'm not Facebook or Google, so I don't need this.
And you're right. You're right. Like most of the time, what people talk about Facebook. Go ahead, sorry. Yeah.
Well, no, so like you said, small enterprise, but I just want to give like order of magnitude. Like when should people be thinking about this? When would you say like, okay, like even though I'm a fan of monorepos, you're too small. Like, don't bother.
It's actually that's a very good point. The word, because we use the word so loosely, right? The word monorepo either means, or like until maybe a couple of years ago, right? Now it's changing, but before that it meant it's either Google scale, which is like this super sophisticated everything, right? The whole stack from scratch, or it's Learner. Okay, so Learner, I would just scratch out like, okay, technically monorepo, right? But really, it's just a task runner. Okay, so task runner is not a monorepo in itself. So just ignore that. That was the two extremes. People are like, okay, I'll look at Learner. It doesn't give me anything really. So why would I care? Okay, this one. Okay, this is too spooky. Like you try to set up Bazel, you spend a month, it's still not running. Okay, so is there anything that is? So the way I think of monorepos in general, and that the word is. We use it's a very bad word because we got corrupted by these two extremes, right? But really, it's more like structured repo. The word structured repo is better in that you can build a single app in your repo, one application. Let's say, for the sake of argument, it's 50,000 lines of code. So it's mid-sized JavaScript app, nothing super huge, 50,000 lines of code in one app, right? But if you're saying, hey, I would like to partition this app into different modules, right? And I would like to make sure that modules have public APIs, so I can, there is some good architecture, etc., right? And I would like to partition, let's say, one application to, let's say, 100 modules, which is not that crazy. 100 modules, they're very lightweight. They're very easy to build. They don't introduce any complexity, really. And I say, okay, now I have 100 modules of different sizes, but they're all fairly small. I can go and look at them in isolation. Each of them have public API. Let's say 50 modules, right? I can test them, etc., right? In this case, is it a monorepo? There's one app in there with maybe an end-to-end test suite, and some auxiliary app to maybe serve some sort of demo version of something. But it's really one system, right? One system, one end-to-end test suite. It's not even that big of a system, right? But if you partition it into 100 or 50 modules, now you have 51, 52 packages, right? If it's 50 modules in your repo, so technically it's a monorepo, right? So is it a in this case, the tooling that, for example, we built, right, works perfectly for that, right? It's like, it's not a big system, right? But there are a lot of advantages in just partitioning things into smaller things, not for the sake of fast. That repo can be fast anywhere, okay? So you can make it that app fast you don't even need to try. Okay, it will be fast. Most systems are like it's very easy to make it perform in CI locally anywhere. Right. The question is not whether the thing is fast. It's more like, well, actually, I can partition it such that it's easier for me just to reason through the stuff. I can open it. I can see different chunks. If you depend on how you architect things, let's say hexagonal architecture or like different slices, like lines of business, I can see all of them, everything in a separate place. There is a public API for every single thing, so there is more structure. When I render depth graph and next renders this beautiful depth graph, I can see it becomes more like a tree. Like it's this tree, and then at the end there is some shared code. Like there is beautiful structure to it that is very hard to ensure if you just have a folder of files, because in folder files anything can go anywhere, right? So like you have a beautiful structure that is ensured by tooling. Tooling would validate that the structure persists, right, statically during CI, etc. So you cannot by accident reduce or import into something you shouldn't be importing, right? So in this case, it's not monorepo. It's not big, right? It's not monorepo in the sense of learner. You're not publishing 20 packages to npm. It's one app you're building with Webpack, right? Or like one Next.js app, for example, right? And it's just you only do it only because you want the structure to be there. Such that when you look at this, you're like, okay, it's structured, it's nice. In a way, when you look at TypeScript, when it's okay to introduce TypeScript? Honestly, at pretty much any scale. If you have an app with 2,000 lines, it's already probably easy to maintain with TypeScript. There is no real downside to having it. It's just a bit more structure. Okay, so maybe if you're just starting with programming, okay, don't go TypeScript right away. Sure, right? But really, if you already used TypeScript before, or like if you roughly understand the value proposition, it's good at pretty much any scale. All right, so it's the same stuff here. If you want a bit more structure that you can ensure statically, right? You just want to architect your things better with one app in it. It's already an advantage, right? So it's really the whole Google scale spooks people away, and that's where the fast matters. If you have one app with 50,000 lines, fast doesn't matter to you, and it's not be fast for you, right? And it's just it's a different concern there. The concern is not fast; it's merely just understandability of the thing, right? So you can visualize it, click stuff, see how dependencies are structured, right? So just that thing can be beneficial because it's like with JavaScript or even TypeScript, it's hard to architect systems that go beyond a certain point, right? If you have 100,000 lines in a single folder, it's not a large system as systems go, but it's already tricky. But if you add a bit of structure that is statically imposed, and just do that, it becomes trivial to maintain. As our clients know, we have millions of lines of code in the apps, like it's sizable, really big apps, right? But because they're structured and there is certain guarantees that the tooling provides, saying like, this thing cannot depend on that thing. Right, lines of business cannot cross, like the bank cannot depend on credit cards. A lot of our clients are in banking, so those type of things. Right? If that is a thing you can impose, suddenly the system is a lot more maintainable, even though it's a big system, right? So it's very different. Basically, I would say at pretty much any scale. If I were to start a system to play around with a new framework, okay, I wouldn't use sophisticated tooling. But if I go beyond that and say, I want to build like a real app of any size. I'm like, yeah, why wouldn't I want to have a bit more support, right? In a way that, why wouldn't I want to have like VS Code or WebStorm to help me out as well? I don't need it for a small app, really. I can figure it out in Vim or whatever, right? But it's nice to have it. It's nice to have it when it's like autocomplete and stuff, right? Even at a smaller scale, it's still nice, right? So
I think when like if you're starting out and people are on board with the idea of Monorepo, it makes a lot of things faster. Like you don't have to set up new CI and new publishing and things if you want to create like a design system and say, okay, let's create the new repo for the design system, and we're going to be building it as we're building the app that consumes it. So now we have like two histories that we have to keep in sync as we like publish new versions of the design system or use something like Git submodules or whatever you do. It's just you get those things for free in a monorepo. You have atomic commits. You can spin up a team really fast in a monorepo. Yeah,
standard benefits of monorepos. There are a couple of things I'm picking up from you here, actually. So I'll give you my two personal rules that have worked for me. One is kind of like so my personal rule for TypeScript is 150 lines of like once I start reaching like 150 lines in Node.js, that I start throwing in TypeScript already, just because I know like that actually speeds me up. But it's actually correlated to your familiarity with the tool, right? If you're more familiar, then you're allowed to apply it at a smaller project. But if you're not that familiar, then the learning curve, it's not worth it for you, and you have to. So you should probably put it off. But one thing as a developer relations person that I've done in the past to convince people to try and learn these things is that it's kind of like learn once and then use it repeatedly on different projects. So you kind of like paying that cost up front, which there is a learning curve, and everything's different and all that. But it's standard tooling, and as long as you have some confidence that it will stick around, then you can sort of amortize that cost over all your future projects.
Yeah. I actually agree with that. That's why when people ask me what to learn, I always say Bash. Learn Bash. Yeah, it takes you a week to learn because it's super fucking hard to understand. But then, for 20 years, you'll be, you've been using it, right? So there is that. So for
You'll
sure,
be the person on the team everyone goes to debug their Bash script.
but this is a good point that in general, the sophisticated tooling, if you look at VS Code is a cool editor. I like it. I actually used it when they released the first beta. I was already on it because I'm like an editor nerd. Any editor comes out, I'm on it, right? And it felt like it was, pretty raw at that point. But anyway, so if you look at it right now, it does so much stuff. It's obviously more complex than using, let's say, TextMate back in the day or something like that, right? It does more stuff. It's harder to learn, but it's worth learning. Like spend a few days figuring it out, and the benefits will be there, right? So if you like, a lot of this stuff is, it's not like you need to take a course and spend 2 months learning this, right? Like you have to spend a few days, like looking at it, playing with stuff, right? And then you have enough familiarity to be productive, right? As the same way you do with VS Code or any other thing, right? Yes, it takes a few days before you are getting used to, some of the things that are different, right? And then you get productive. As a side note, I just want to make clear, because people always misunderstand this in regards to NX, I would start with that. There are sort of 2 tiers of NX. The NX core tier is basically like a free addition to, like, say, Learn or Yarn, where you don't have to learn anything. It's just the same. It's literally the same. Your yarn remains exactly the same, so there is no difference, right? So, but a lot of advantages comes out if you want to take more, like that doesn't help you with org scaling, for example, right? If you take a bit like a step forward, in a way, again with VS Code, you can add VS Code. It'll start using it as a text editor, and it's cool. But you really need to explore plugins and other stuff to see why it is really cool, right? So there is like sort of two degrees of coolness, right? You don't have to do all of this stuff at first. It's more like once you get used to it, it's same as TypeScript though. You can use TypeScript with any JavaScript file. Just enable language service, LTS config. Your JS file will be TypeScript analyzable. But really, once you bind the TypeScript and you start using it a bit more, then you see, actually, writing down an interface helps me, right? It's not just a cost. There is actually a huge advantage to that, right? So it's the same kind of stuff. It depends. You don't have to learn everything. You can start very small. In this case, you can be up and running in half an hour. But the more you learn, obviously, the more gains, in your productivity you will see, right? Right now and sort of in the future.
Yeah, got it. It's something that I'm definitely picking up from you guys is the importance of UI. I personally been a bit critical of the dependency graph before, because I think that people, it's like either it's a nice demo, but in real life projects it's too big. So you're never even going to use it anyway. It's just like a nice thing to put on slides.
That used to be the case with ours. Ours, when we made it interactive, it became a lot more useful.
Yeah. So
it has to be interactive.
Yeah, exactly. Our first version was the same. It's basically a graph with visualization. Okay, that doesn't work. If you have 50 projects, it's useless. But when it's interactive, it does work, because then what you can do is you can say, I would like to render this graph. And actually, if you look at on a website, you can see a video of my adding next to a React repo, right? And you can see the graph of the React repo, right? The React project, the Facebook repo, right? And you can see it in there, right? Is
this like the landing page? This one?
Oh no! Let me show it to you. Let me send it to you.
I like to put it on screen so that people can follow along.
Yeah, because I think that's one of the cooler. Because there I'm only using core, and I'm just showing.
Yeah, I actually ran I think dependency cruiser on the React repo as well, and I was like, okay, like this is cool, but also I don't know how to export this.
No, it's let me. So in this case, if you open this. This is a YouTube video, but you can just, you don't have to play the video. If you, let me find the right moment for you so you can see the graph. Oh yeah, cool. That's a good moment.
You could screen share, Victor.
Okay. Okay. I hope I don't have anything weird open.
We'll find out.
I don't, it's not really weird. It's just, sometimes you have, like some personal chats with your partner and stuff, and then now.
Well, you can always constrain it to just the browser window.
You'll be surprised how much stuff my browser window has as well. Can you see it?
Yes, I can see it.
So this is sort of an example.
This is
nice. Yeah. So and I just zoomed in on one part of it, and I say, a React DOM. I want to see inbound and outbounds, and this is useful for a few reasons. You can see things like well, if I have a cycle, why the cycle isn't there, things like that. But the important thing is that if you have a large enough graph, and large enough graph, React repo is actually a tiny repo by enterprise standards, right? But like, or 50 projects or something, right? If you have that, even at that scale, you already have to have interactivity. You need to be able to filter stuff down, focus, remove parts you don't want to see, because otherwise it's most, especially and one side note, repo is like that messy is because there are no, React repo actually is well maintained. I don't want to say anything bad about the team, like they're doing fantastic job, right? But most repos are messy because there is no force structure. Right? If your enterprise repo says, if you look at the repo that folks are like a learner repo, for example, that folks are maintaining, it's a mess. It's just like this. Everything goes all directions. It's just a big ball of mud. But if you have structure in post, your graph will reflect it. You will see like different lines of business in their own clusters, right? They don't intersect because they cannot. The tool prevents them from building edges over there, right? But even here, if you see this, the depth graph stuff, it is useful. So it wasn't useful for the first year or so when we had it, because we had a simple sort of generate a static image, download the image, right? But now when we added interactivity, and the interactivity was there for years, but with the interactivity, you can say, oh, I'm curious about this library I'm working on, right? Let's look two levels deep. So basically 2 levels in direction, 2 edges in all directions. Excludes or share that because everything depends on share just messes up my graph, right? You just do a few things and you're like, okay, I see if I change this, then anything over there is going to be messed up. I need to talk to, I don't know, Julie or something, right? Who is maintaining that piece, right? It actually makes a difference. It helps with exploring, and it helps also with once in a while when we do if you don't have good rules set up, because I'm not a fan of setting up good strict rules in advance because it never works, okay? But you look at this, let's say once every couple of weeks and saying, let me look at the graph now. You're like, oh, what happened? The graph got worse. And things just got messy. You're like, look at this. Oh, there is this weird edge introduced. You find out the PR is saying, okay, that shouldn't happen. Let's untangle it and introduce a rule that cannot happen in principle. Like the linter will fail you, right? And the graph goes back to normal shape and you're happy. So you do sort of once in a while, you look at it, like maintenance kind of thing. You look at it as you might attend to a garden or something. Okay, that thing got crazy. Let's uncrazify it and add some rules to make sure that the reason why it got crazy in the first place doesn't occur again. All right. And in this case, your graph ends up being reasonable. So you have like normal clusters, right? We have clusters maintained by different teams because at the end of the day, that's what you want. If you have, let's say, 3 or 4 teams, you want 3 or 4 clusters. So every team is kind of in their own cluster that depend on some shared clusters, right? The code they choose to share, right? And it's not hard to establish your solution. Once you establish and you have a good viz, it's actually fairly easy to see whether you follow it or not, right? So it can be handy, but you're right. If you do it naively, like naively as in not in a stupid way, but in like the most basic way, your first attempt, right? If you do it as in your first attempt, then it is not useful, right? It's the same with pretty much anything that is sophisticated enough. The moment you start reaching certain scales, the first attempt doesn't work anymore. The same with fast. Yeah. Like it's pretty easy to make things fast after a certain scale. Then like, okay, now it has to be like it's 100 times harder to build this version than to build the graph with version, obviously. But you sort of have to, at some point, every time you break this point, you're like, okay, now I have to rethink it and redo it from scratch. All right, that matches that works for the small scale as well, but also can work for this scale, right? You basically have to do it from scratch. You can incrementally get easy into it, right? Because that implementation is a sophisticated React app that renders all the stuff you can do things with, etc. Right? Our first thing was a graph with, which is a utility you can work and say, this is a JSON document render, right? Those things share nothing in common. They share nothing in common, okay? So you basically have to throw away your first attempt. Okay, now I'm going to redo it from scratch. And it takes 100 times as long. And the same is performance. It's very easy to be fast until a certain point. Then, now I need to distribute, okay? Again, 100 times harder, but then so it's just one of those unfortunate things. Every time you reach it, don't try to refactor it. Okay, no. Just like you have to at some point say that good try. Let's do a V2 version that works for the scale.
It's a very similar problem to Temporal as well. Like a lot of people can build their own sort of orchestration framework, and then eventually you start to need someone that is more considered and battle tested. There's so many things I want to talk to, which I'm really excited about. You mentioned there's like the sort of free tier NX. I don't think we talked about like the premium tier. Did you want to explain like what's in there, and then is that like a SaaS offering, or what's going on there?
I think you may have used free in like a more metaphorical sense, Victor, of like the core being free. Like
Okay, let me make
it's free as in it's community,
Yeah, let me state it very, very clearly so there is no misunderstanding. So the Annex itself is an MIT licensed open source project that is free in both as in beer, as in speech, right? It's free, it's an MIT licensed project, and it always been. From day one, we did, like, it was, it's very important for the whole open source thing, the community stuff. I think in the long run, open system, decision that the open source and open in all sorts of ways. We can talk about that separately. The win, so we like, that's not, and there is an xCloud, which is a SaaS product, right? That is a separate product. It's lives on a separate website. It just happened to provide distributed cache and distributed task execution and the UI for Annex. Annex Cloud has a free tier, right? So you can use Annex Cloud for free. But if you're an enterprise or if your project is very large, right, at some point you have to pay to get distributed execution and stuff. So basically the Annex itself is MIT licensed, free in all meanings of the word free. And Annex Cloud has a free tier as in free beer, but not as in free speech kind of stuff, right? That makes sense. Just to make it clear, because I think the importance of
there's a lot of other, like, there's some things that are metered on an xCloud, but there's a lot of like insights into your runs and like your builds and branches and things like that is free and not metered at all. So so we've made it to where every NX workspace should be able to use it and get lots of value even if they're not paying anything for it.
That's exactly right.
So maybe this is I like asking this question of founders. What's one thing that you discovered in serving this different market? It's like a paid, premium at scale market. What's something that you discovered that you didn't expect?
The pricing model, like the pricing has been a constant struggle because we've tried to come up with a pricing unit that makes sense, that aligns what you're paying with the value you're getting, and so we actually charge by time saved with NX Cloud.
What?
So it's like we compute the time it takes to run the task, and then we subtract the cache hit from remote cache hits, and basically that's the time saved.
Yeah, how long to download the artifact, right? So and the delta is what we charge for. And same as DT. We look at this stuff and say, like, we have a way to pretend you distribute without us, and we compare with your distribution without us, right? And it's not perfect, but it's
it's great. I think because you're a build system, like you actually have a justifiable claim on time saved, and that is a thing that people can compute on their side and say, like, okay, I pay my developers this much, like, and then you're like, oh, we're 5% of that, like. It's easy.
And the speed, like, so with everything we've built our business on, like, the speed to market is the biggest thing that sells. And so and teams are really starting to see the connection between build times and like time to merge requests, how many features get merged in a cycle and released, and starting.
They're struggling, you said?
They're starting to realize it. So because if you can get a product to market a week sooner, for a lot of companies, that's millions of dollars more revenue that's realized rather than delaying a feature, like a bank getting a new credit card to market or something. It may be that may be the case, or like any real product. Like most teams we work with are product teams, so we're not working with so much like back office applications. Platform, it's mostly the teams who are working on the product that makes the company money. And that's so the developer time is one thing. Product time to market is an order of magnitude more valuable to the companies. So, like, people conceptually, so with enterprise, they don't. I don't want to say they don't care about the cost, but like they care a lot more about things like predictability, about reliability, and things like this than cost. So like. We have an enterprise version of this that's a lot more geared towards enterprise buyers, but the public thing, that NX app, the full SaaS thing, is where, like, we get people hung up on the unit being somewhat obscured. So like the billing unit being something that they have to trust us to compute. They don't know what it's going to be. So it's something we're always working on to figure out. Okay, we'll be changing it more to make it something simpler, but we didn't want to do something that's just like, you pay for bandwidth or something like that. It doesn't really reflect the value.
That's actually the thing that I thought when we came up with this time save. Like, okay, we have the information, we can actually fairly accurately tell you how much you think would, like, really with a good estimate, right, of legit value provided. So if you don't derive any value from us, and even if you're a super large project, well, you're not paying anything, so like, why? And it's given that if you look at, most providers, you're given like, you get 450,000 units of utilization, whatever that means, right? And you're like, I guess it is what it is, right? So like, isn't this better, right? And people are still like, well, I think it's because utilization is so obscure. They're like, okay, there is not like, it's just a thing that comes up, right? And here, like, time saved, wait a second. But if I try to optimize my CI slightly different, that time saved won't reflect. Because it's close enough to something people can understand this, and they're like, okay, now this is an uncanny value of things where they can understand it, but it's not perfect because we cannot do it perfectly. There is no we don't have normalized environments where time is measured perfectly or anything, and it's a good estimate. That's what it is, right?
Yeah.
And the good news is there's enough. We've added so much value to NX Cloud over the past year that the subscriptions have gone up despite the hesitations we still hear with the pricing model.
Yeah, but
enterprise especially.
I just want to point out one thing that Jeff mentioned, that there is basically two parts. There is what this fast part, this distributed task execution is what gives you fast and your cache and stuff. That way, if you after a certain scale, we charge for. But the second part is the UI and stuff. Like if you run 1,000 things, you want to see it beautifully in the UI and integrate in GitHub. All of this stuff is always free. Right. So if you're really saying you can make things fast because you want to roll out your own cache, well, yeah, go ahead. That's fine. You can still use NX Cloud just for the UI stuff. So you get the better ergonomics. Because I think that re-implementing cache, surprisingly, is not that hard. Re-implementing the UI is very hard. Okay. So like if you want to have a UI that works for like 1,000 projects run and everything is, blah, blah, blah. So there are a lot of things in there that are free. Where because we know that if you want to really take advantages, you have to have them, and it's very hard to build yourself. So we would rather have you, right? Have this stuff, right, and use it. An example, for example, would be if you run a thing and you see a cache miss, right? If you have just a cache miss and you have no way of troubleshooting why it's a miss, okay, that sucks, because then you'll be like, okay, I keep receiving cache misses, I don't know why. So we have a built-in sort of analyzer that tells you like what was a near miss, something very similar, and what was the difference. You say, and you think that should be a cache hit. Well, actually, that thing was different between these two runs, right? Maybe you're changing something in the CI, some file, you keep modifying it, something, right? Package the JSON, something like that. You include like things like that are hard for people to build on their own. And honestly, I think it's fine for them to have it, because at the end of the day, you have to have something like this to use an X at scale. And our goal is always for folks to use an X for like interesting things at scale, etc. So all of those things are always free. But in terms of speeding stuff up, like DTE and stuff, okay, that's after a certain point, you have to pay for.
Yeah. So my relationship with this problem, and we can talk about Temporal next, but we charge based on state transitions. Because we are a state manager, or we don't really do compute for you, and then you have to trust us on how much state transitions you consumed. So it's a very similar problem, but
how has it evolved? Is that how you started, or did that come about?
It's how we started. We've had it for a year, and we're about to change it. So we're trying to improve. I think honestly, like it was never going to be a something that we did long term. It was just like an easy first cut. But I think honestly, like every pricing scheme eventually tends towards charging for the core pieces of cloud that people understand. And for me, it's storage, compute, and bandwidth. And then you can do like the high performance versions of that, which is like memory, GPU, and sockets. So I'm trying to create this general theory of cloud. Like these are the core pieces that you mix and match them to create your special thing. And you don't have to charge on that.
I've talked with friends who've done things more in the production orchestration vein, and one of the things regarding pricing that he had said to me was, I wish we'd just done everything based on memory, because that correlates with who's got the more heavy duty workloads, who's got the budget. Like it would make things so much simpler.
Yeah. I mean, I do want to for Netlify. So Netlify went from seats to like 7 different dimensions, and then each of them had different add-ons. And very pretty much like you like it's hard. You need a spreadsheet and like 1 hour in Excel and an accountant to like figure out how like how much it's going to cost to try you out. So I'm a bit worried about going too far, but obviously charging for value is the right way to go for SaaS.
Yeah, it's funny. Like folks see all these products and the pricing schedules and just assume that everyone knows what they're doing, but really we're all just experimenting, trying to figure out how to get the right money from the right people and give a good deal to the right people.
Yeah. Yeah, because at the end of the day, you want to say that if you're a small project that benefits a little bit, well, you don't pay anything, right? If you're a larger project, like if you're a bank and you're, saving tens of thousands of hours per week, well, maybe you should be paying more, right? So, like, I don't know. That's basically, so there is some notion of fairness baked into it. Like if you benefit a lot, well, then you share the benefit, right? You get some benefit from the product, well, you share some of the benefit with us providing the product. If you don't get any benefit or very little benefit, well, then why are you paying at all, right? So I like this in principle. It is surprisingly hard to convince people that this is fine, because you're like, you know what? You say I benefit for $30, but actually it was $28. It's like, oh my God, like it doesn't matter.
Nickel
Like
and
that's
diming.
yeah. Like if I just said utilization and it would have been $50, it would have been okay, because like, well, it's 7 million units of utilization. It's the same when you look at your cash, like credit card, and you have like, you accumulate 250,000 points. You're like, well, I guess I did. I mean, I don't know. Right? Like, I imagine it's correct, right? You're telling me, so I can buy like a toothbrush and whatever, and something out of those hundreds of thousands of points can let me buy.
Cool. Yeah. So maybe we can transition to. I know you said the DTE stuff is easy, but what did you want to find out about temporal?
DTE is the not easy.
DTE is the hardest part. Like I think the rest of it in combination is easier.
Distributed caches.
Yeah, cache is easy. Cache, honestly, cache like your computer file, you have cryptographic key, so you can only one. So that's easy.
DTE is easier compared to the organizational side.
I think that so let me adjust for that. I think that for most organizations, doing a bespoke distribution is easier than creating good organization and good architecture. That bespoke distribution sucks most of the time, right? So just to not to make it sound like DT is like, people can just no. DT is very hard.
We can move on.
Yeah. So we can move to that. Like the thing that you were saying. You said there people solve DTE in two ways. One is kind of like sharding into tasks. I don't think you got to the second way, but for me, like my immediate response is put a queue in the middle, right, and then have workers pick off of the queue. Is that the second way, or?
Okay, so that's a good point. So there is always some queue somewhere, right? If you want for things to be because essentially what it boils down to, if you shard in advance, it just doesn't, just scrap it. It works for like a smaller repo. For large repo, it doesn't work, right? You have to have some sort of ordering implied, and some queue, and whether you pick one item from a queue, have a way to pick up groups of items, that's a separate thing. But you have something that the workers or the agents would get, pull work from, right? And then they execute the work and convey the results of the work back to some sort of orchestrator or whatever, right? The reason why I meant the queue is that, with something like a queue is required, is that for some tasks, if you imagine, for example, a build, right? You're building, let's say, an app that depends on 100 libs, and those libs depend on each other. So every lib has to be built, and they have to be built in order. Like you have to build shared components before you build some other lib, because that other lib requires the result of building shared components being there. Right, it consumes the gist folder of shared components, right? So the ordering matters, right? So the ordering requires you to understand the task graph. So you have to look at the task graph and say, well, I cannot just shard it, because sharding works basically where task graph is flat, basically a list. If you're saying, if I have a flat list, then I could whether divide in advance or pull from a queue. The moment it becomes not a list, where things depend on each other, and have to execute in the right order. Like imagine you have to build things first before you run end-to-end tests, because you need to solve the build artifact, right? So in this case, you cannot build on one machine and run the test on another machine. No. Like build has to run first on whatever machine. And then whatever machine runs end-to-end test has to have the result of build there. So it can point node to the results of build and run the app, right? So the order is what makes things a lot trickier, because now you're saying that instead of a flat graph, essentially a list that I can chop in all sorts of ways, right? I have a complicated graph, usually many graphs, because you run many commands at the same time, etc., right? And some of the graphs are very shallow, some of the graphs are deep. And now you say, now I need to look at those, let's say you 4 graphs, you run build, test, lints, and end-to-end test. You have 4 graphs because 4 commands, right? And you're saying, I want to run all of those 4 things using my 20 agents or something, right? In a way such that the agents stop executing around the same time. Like you don't want to run it such that all agents run, then one agent will run for 20 minutes more, because that's just, that sucks, right? You want to do is, okay, I want to run this work somehow such that all of these 4 commands, 4 graphs are processed. And the result is that it all ends up being around 10 minutes, for example, and everything stops at 10 minutes around at the same time. So utilization is even. That's sort of the why.
Unless you have unlimited workers, when it should just stop whenever the longest running task is done.
No, but even then, if you have an order, so you need to say like then you need to start picking up the task.
Yeah, that's
if unlimited things, you're right. But if you have some sort of limit, you need to say that. Anyway, so those are the complications that make it non-trivial to do things well, right?
Basically, halting problem as a service.
Yeah, so I'm not sure.
Don't send Victor down another rabbit hole.
Yeah, so but I think that is the tricky part, because basically one of the things that we do is if you run the GGs, or like for example, our next repo itself uses GGs, and you see them the agents, you can look at utilization and say, is it even, right? And we can help you to figure out how to make it more even and stuff, right? And the tool can help you, right? But that is the tricky part. It's hard to get it right.
So with Temporal, what are the types of tasks that are being distributed?
Okay. So and stop me if you need me to go up and do a more high level thing. But types of tasks, we just call everything. We separate everything into workflows and activities. Activities are just general purpose, like side effectful stuff, and then workflows are orchestrating activities. And that's kind of like the high level separation of concerns. So there's no prioritization, or rather, there's no native prioritization. You can sort of write your own prioritization logic inside of the workflow activity, the workflow function itself. But it's a very simple separation, and then the workers kind of pick up work from a central queue, which is why I talk about that's that kind of queuing logic. So there's no intelligence.
Like from what I've gathered from Temporal during this conversation and looking at it beforehand, is it concerned with data, like of processing data across across services or microservices?
It's general purpose, but so when you say data, are you talking like are you closer to Airflow and Dagster? Is that your question?
Is it like state or persisted data that's being managed across different slices?
Yeah, it's more state. It's more like state. You can't put like giant blobs with us. So yeah.
Cool. Sorry, I derailed you.
No, not at all. No, I want this to be useful for you as well. And if there's any way that our companies can work together, that's also interesting. But it sounds like you're quite a few years ahead of us in terms of solving.
We're just solving a different problem. With solving it in a similar way.
Because like for me, like what Victor was saying, like it involves predicting, like a few steps down the line what their requirements are going to be, and then planning that ahead of time. We don't have anything. I mean, nothing's built in. You can write it with us, but we're not that layer.
Yeah. Yeah, and ours is based on an understanding of your source code and historical, knowing historically how long tasks take to run and things like
how many agents you tend to have and a bunch of other things. So we if you on average tend to have like 20 agents during the round, we're like, okay, it's once we start figuring out how to partition the work, we can take all the things into account and get a pretty good result, right? For most, where like your CI will be utilization will be like roughly even, right? So it's but yeah, there are. Go ahead.
Do you have a system to take hints from the developer?
Yeah, you can kind of figure like for some extreme cases, some of our clients have very like super duper large tables, right? Like like massive systems where because you optimize for what you look at. You say, okay, most of those things are that. You look at that. You're like, okay, let me, because a lot of it is not like theoretical math. We're like, this is a perfect. This is you have a bunch of heuristics. You run a bunch of algorithms to use those to compute what roughly you think your sort of execution plan would be for the CI run, right? With all those commands, right? So if you have a CI run that's very different, right? It can kind of screw up some of the assumptions. Like so, you can provide hints to account for to battle that, right? If you have a very weird workspace, well, you can tell us a bit more, so we don't have to be that smart, right?
Gotcha. Yeah, I mean, for us, like I feel like we're we're still trying to figure out what our term is right now. For us, we call it microservice orchestration, but people do build build sort of CI systems with us, but then they also use us to do human in the loop stuff. I think I don't know. I don't know where this discussion can go, but anything you had questions about, I can answer.
I'm reading through the docs right now, or the use cases right now.
Exactly. Okay, sure. The way I tend to explain it is like durable timers, human in the loop stuff, because you can send in signals to a running workflow and have it change course, which a lot of workflow systems aren't set up to do, surprisingly. You need something more complex than just cancel. You need to be able to query internal state. You need to be able to modify internal state, and then have the workflow respond as a result of it. And then you need every single part to be fault tolerant in terms of if any part of your system goes down, your server goes down, if even Temporal itself goes down, all you do is bring it back up again, and it picks up where it left off. And then you need every single part of the system itself to be horizontally scalable. So if you experience any bottlenecks, you just throw more machines at it. Those are the main principles that I think about.
No, that's interesting. No, it's actually an interesting thing. It reminds me of my earlier days in my career when I was doing event sourcing, kind of the pipes and filters where your messages flow through. Yeah, and then you have persistency where you can crash the thing, but the queue is persistent or whatever. All of those things. Like it was like a lot of fun. So that is interesting.
Something I'm thinking of pitching actually is it's the one stateful component in your system that makes everything else stateless.
Oh, interesting. Yeah. No, I can see that. Yeah, the event sourcing I think is it's what the closest thing I attach to as the closest idea where you send essentially mutations or whatever, right? That commands, right? That result in a state change, and then most of your things then just either sends commands or react to a stream of updates from views and stuff, right? So that's cool. That is it.
So you get scalability and you get observability for free as well, and then fault tolerance.
But that is very cool.
And I see you've got what looks like maybe a monorepo for the temporal server here on GitHub.
It's the beginnings of a monorepo, but it's not monorepo yet enough. I think we'll still have to make some switches. But
we're on a quest to NXify all the open source monorepos. So at some point, Victor will do a demo video. Do
you care about languages? Because we're mainly Go.
No, we work fine. We have a Go plugin if you want to have more rich support, but really the whole, because there are two parts where
there's a community Go plugin. We don't maintain it.
Yeah, the community one. That's a good point. Yeah, there are two parts that we care about when it comes to languages. One is analyzing your source code, because we are a Monorepo too, but we don't require you to configure your Monorepo. We look at your source code and we know how parts relate, right? You don't need to tell us, which I think at scale becomes a big deal, because if you have 1,000 nodes, you don't need to do anything, right? We just know what those nodes are. So then we need to understand the source code, and that's where languages kick in. And the second thing is,
by the way,
being able to run tasks. Yeah,
I didn't mean to say the Go plugin isn't good. It's a great plugin written by a guy who really knows what he's doing. I just didn't want us to take credit for it.
Oh yeah, for sure. Yeah, so it's a fantastic thing that we didn't do. Right. So, but yes, it works with it can work with any language, but in practice, it works with a few languages that people have the source code analysis for, right? Because that's the magical part. If you don't have the source code analysis, you have to basically tell us what nodes, draw the edges in the graph, which anyway, that sucks, right? So you can see we can rant about why it sucks, why it never correctly set up, etc. Right? So NX,
which I think is probably true of Turbo too, is it doesn't care what the technology is. It can do anything. It can even invoke your own scripts for building stuff.
We're still going to have packaged the JSON right now, right? So in general, yes, you can drop them in any source code. But in our case, you can tell, if let's say you have you can basically teach NX what it means to run a thing in your, let's say you have a Java with a bunch of Gradle files. So you can say, actually, I can teach NX to invoke tasks from a Gradle file, right? So in this case, I don't need to configure anything. You just write your Gradle files as you would normally do in Java, and then
the plugin does the heavy lifting.
Yeah, the plugin will look at it okay, you can run those 5 things, right? So you can run them in the same way you would run anything else. Okay, so my baby woke up, so I will have to go and attend to her. So really sorry, but it's just something that
Yeah, but I think
Dead life.
we'll look a little bit more into temporal on our end
it looks
play
very
with
cool.
it. And because new technology is exciting, especially open source stuff. But I'm sure there's some interesting things to do together.
Event sourcing is a winning strategy. Honestly, like queues and reduction of events into views that you can query is the solution to not all problems, but to many
distributed transactions correctly. Which is something that we. Okay, let me stop recording.